welcome back to our channel. I am Anisha, your maths faculty for class 12. We have started the chapter 5 of class 12, that is continuity and differentiability. And in this, what we are doing is we are solving each and every questions for NCERT book. We have started with exercise 5.1. So in this video, we will cover the question number 17 and 18 of exercise 5.1. Let's move ahead in this video. Okay. So in this way, we have first question is question number 17 of exercise 5.1. So first of all, always read your question carefully, make the given statements, make what we have to do. Then your question will be very easy for you to solve. So let's read the question carefully. For in this question, we have to find the relation between a and b so that the function f defined by f of x is ax plus 1 if the function f of x is defined as ax plus 1 for x less than equals to 3 and bx plus 3 for x greater than 3. Now, what we have to do? We have to find the relation between a and b. Your function is defined like this, such that the function is continuous at x equals to 3. So, okay, what we are given? We are given with the function. F of x. Now, what we have to do? Like we have to find relation in a and b such that f is continuous at x equals to 3. So we will use just what we don't have to do anything. Whenever what you have to pick, see what we have to do. We have to make the function continuous at x equals to 3. So just use the definition of continuity. For the definition of continuity, we have the function value, that is f of 3, must be equal to limit value, that is limit x tends to 3 f of x. Now, as you can see, our function value, that is f of 3, is nothing but it is defined as ax plus 1. Now, this is our function value. For limit value, if I try to write here, so our limit value, we know that the limit value exists. For that, to take the limit value equal to this, our limit value must be equal must be exist. For its existence, we know that our left hand limit must be equals to the right hand limit. So let's proceed with this. So we will proceed with this here now. So what is our left hand limit? As you can see, our left hand limit will be limit of x tends to 3 minus f of x. We know that this is nothing but ax plus 1. So now similarly for right hand limit, our right hand limit will be limit of x tends to 3 positive f of x, and we know that our right hand limit, okay, in place of in place of x we have to write 3, right? Because we are like taking the left hand limit at 3. Similarly, right hand limit at 3, this will be 3b plus 3. Now, for the existence of the limit, the left hand limit and right hand limit must be equal. So for that, what we have, our 3a plus 1 should be equals to 3b plus 3. And what we have, this is like if they are equal, and this value will be our limit value, and we know that for the existence of limit, this must be equal to our function value. And if I try to equate this by my function value, we know that my function value is nothing but 3a plus 1. So from here, what we want, from here what we get, we only need to do 3a plus 1 is equals to 3b plus 3. As you can see, this will be turns out to be 3a equals to 3b plus, it's now easy calculation for you. If I try to simplify it, it can be written as a is equals to b plus 2 by 3. This is the relation what we want for the in a and b for the given condition that the function is continuous. So this is our required answer. So what we have did in this question, we just apply the thing what we have to do. We have to find the relation in a and b where the function is continuous at x equals to 3. So we just started with the condition that the function must be continuous. We just apply the definition of the continuity at x equals to 3. We got our relation. Now see, this is a very important type of question in the board, because it's kind of you have to find some relation. If I make it star, it's a very hot question for the board, but by the way, I'm not making it as important. It is very hot question. Why it is a hot question? Because it's what you are doing. You are just applying your way of using continuity in a function. So this type, in board you have what you have two types of question. First one is like the basic. Basic, that means that ask for your basis for the question, for the like particular chapter. And the another one is the application of that basics. So that we have did here. We just use the definition of the continuity here and find our relation. So this is very hard question, and I think you have to do this type of question a lot so that you can get a good practice for that. So let's move to the next question. This question is also like kind of this form. So this is question number 18 now. This is also I'm just listing you the hot questions, okay? Why? Because I know this type of questions are board favorite questions. So let's move ahead. We will do this question. This question is same as our question number 17, but like conditions are different only. So what the question is saying. For what values of lambda the function defined by this is continuous at x equals to 0? And what about the continuity at x equals to 1? Okay, so like this will be very easy to like check the continuity of the function, because as you can see for x equals to 1, you just have to find the function value, like equate with its limiting value. You can easily see that I will just give you the what will be the answer, that is continuous at x equals to 0, x equals to 1. This is homework for you. You will do the calculations. It's very easy. You can easily find that the function is continuous at x equals to 1. Now it's like just diverting you from the main question. But what is our main question? We have to find our lambda for which the function is continuous at x equals to 0. So let's begin with that. So we have to do find lambda such that f is continuous at x equals to 0. So let's begin. So for that, what we have to, whenever we have to like check the continuity, what we always do, we always find first of all function value. So our f of 0, it is, as you can see, it is defined as lambda. Put the 0 in place of x, so this will be 0. That is nothing but our function value is 0. Now let's check its limit value. So as you can see, for limit value, for like when you are approaching in 0 from the left hand and right hand, you have different kind of functions. So what we do, we will first find the limit. For limit, what we will do, so first we find our left hand limit, then right hand limit, then from them we will conclude our like limit. So our left hand limit will be limit of x tends to 0 minus here our function value is lambda x square minus 2x. As you can see, if I like go put my like, if we to find its limit value will be 0. It's very easy for you to find its limit. So now its limit of x tends to from the positive side, that is from right hand side. So it will be defined as 4. The function is 4x plus 1. So this will become to 4 multi 0 plus 1, that is nothing but 1. Now as you can see, your left hand limit and right hand limit, they are not same. So this implies limit not exist. If limit is not existing, then there is no point to check its equality with the function value. So from here, what you have find, the function is not continuous. Right? And you can see for continuity, what we need, that my left hand limit should be equals to right hand limit. Okay, so what is our left hand limit? That is 0. And what is our right hand limit? That is 1. As you can see, whatever lambda you choose, because there is no use of lambda here. So whatever lambda you choose, there is no possible way that your 0 is equals to 1. So this is not possible. Not possible for any lambda. That means our conclusion is the function is not continuous for any type of lambda. The function is not continuous at x equals to 0 for any type of lambda. And I have already told you what about the continuity of 1. That will be, you can like, this is homework for you. So what I'm trying to say, as you can see in question number 17 and 18, both of them are like same kind of questions, but like asked in the different way. But what you have to do, you have to just use your basics, that is how to check the continuity of the function. Then you have to find the some relations. That is very like basics, very important type of questions. You should like practice this type of questions a lot. So we will do this exercise questions, and this types of question will come a lot in your book also. Also, I can, if you want this type of question more, you can follow the like examples also, examples of this book, NCERT book, that also contain this type of questions. So that's all for this video. Do your these questions by your own. If you have any doubt, please ask me. There is no hesitation. You can easily ask me for these questions. Just told your doubt, or ask me your doubt in the comment section. I will like solve your doubts as soon as possible. And for till the next video, please like, share, and subscribe this video so that you can easily get these videos as soon as you want. So thank you.